14 days into the blackout. Your neighbor knocks. He offers you 5 cans of food for 1 hour of phone charging. You can't help him. You turn him down and walks away. 2 days later, you see smoke rising from his house. He's burning his furniture for warmth. By week 3, his house is empty. He's gone. Power isn't about convenience anymore. It's about survival. And if you're still sitting there, waiting for the grid to come back online, you're already losing. Today, we build a power system from garbage. I'm going to walk you through 4 methods, each one more complex than the last, and with a decreasing margin for error. System 1. The basic biogas digester. You need a 55-gallon drum. Plastic is fine. Metal will corrode, but it'll last long enough. Cut a hole in the top that's your input port. Drill a smaller hole near the top edge for your gas outlet. You'll need a tuba garden hose, vinyl tubing, anything airtight. Run it from the outlet to a collection reservoir. A heavy-duty trash bag can work. A rubber bladder is better. An old inner tube is ideal. Now for the chemistry. Fill the drum about 1/3 of the way with water. Add organic material, food scraps, grass clippings, whatever you have. Animal manure gives the best methane yield. Human waste also works. Yes, your own. Survival doesn't care about your comfort zone. Mix it all up until it's the consistency of a thick soup. Seal that input port tightly. The bacteria inside get to work immediately through anaerobic digestion. They eat the organic matter and excrete methane and carbon dioxide. Temperature is key. Below 50 degrees Fahrenheit, the process grinds to a halt. Above 90, you risk killing your bacteria. The sweet spot is between 65 and 75 degrees. In winter, you have to insulate the drum, bury it partway, or wrap it in old blankets. In summer, keep it in the shade. You can expect to see initial gas production in 2 to 3 weeks. After that, it's a continuous process as long as you keep feeding it. So what does this get you? 1 cubic foot of biogas contains about 600 BTUs of energy. That's enough to boil a liter of water. A well-maintained 50-gallon digester can produce 3 to 5 cubic feet of gas per day. That's 3 cooked meals. That's sterilized water. That is the difference between surviving and starving. A serious safety warning. Methane is odorless. It's also explosive in concentrations between 5 and 15% in air. Never collect it in a sealed rigid container. Always use flexible collection bags that can vent excess pressure, and always use it in a well-ventilated area. Asphyxiation from oxygen displacement is a silent killer. System 2. Solar thermal mass storage. Forget solar panels. They require infrastructure you just don't have. Think simpler. Think thermal mass, the ability to absorb heat and release it slowly. You need containers, glass bottles, metal cans, clay pots. Fill them with water. Water has one of the highest specific heat capacities of any common material. 1 liter of water can store 1,000 calories of heat energy for every degree Celsius it warms up. Paint your containers flat black. This will absorb about 95% of incoming solar radiation. Arrange them in your south-facing windows, or north-facing if you're in the southern hemisphere. To optimize, put reflective surfaces behind them, aluminum foil, mirrors, even white-painted boards. This can increase your heat absorption by 30 to 40%. At night, you need to insulate the containers. Use blankets, cardboard, anything to trap the heat inside. How well does this work? On a clear day, a system of 21-liter bottles can absorb around 15,000 BTUs of energy. At night, it will release that heat over about 8 hours. That's enough to keep a small, insulated room at 55 degrees when it's freezing outside. It's not comfortable, but it keeps you alive. System 3. Thermoelectric generation from fire. For this, you need 2 things: a temperature difference and a thermoelectric generator module. You probably don't have a module, but you can improvise the principle with thermocouples scavenged from old electronics. Look in computer power supplies or automotive sensors for something called a Peltier chip. These are solid-state devices that generate a small amount of electricity when one side is hot and the other is cold. The efficiency is terrible, only 3 to 5%. But in a collapse scenario, terrible efficiency is infinitely better than no power at all. Mount the cold side of the chip against a heatsink. Aluminum works. Copper is better. Attach that heatsink to a metal plate submerged in cold water. The hot side goes over your fire. Use a flat piece of metal to distribute the heat evenly. The temperature difference creates a voltage. It's a small voltage, generating milliwatts to low watts, but it's enough to charge a phone over several hours, power an LED light, or run a small radio. You won't be powering a refrigerator, but you will have light and communication. In the dark, information is survival. System 4, a pyrolysis reactor for synthetic fuel. This is advanced. This is dangerous. It also has the highest energy yield of anything on this list. Pyrolysis is the thermal decomposition of materials in the absence of oxygen. You're essentially cooking plastic and organic matter to break them down into simpler hydrocarbons. The output is a crude bio-oil and syngas, both of which are burnable. You need a retorta-sealed metal container that can withstand high heat. A steel paint can work for small batch. A modified propane tank is better for scaling up. Never, ever use a tank that contained propane until it has been thoroughly purged and cleaned. Residual gas plus oxygen plus heat equals a bomb. Load your retort with feedstock. For plastics, use only polyethylene and polypropylene. Check for recycling codes 1 and 2. Codes 3 through 7 will release toxic chemicals. Add some biomass like sawdust, paper, or wood chips. A good ratio is 3 parts plastic to 1 part biomass. Seal the retort. Run a steel pipe from it to a condensing coil submerged in cold water. As you heat the retort over a fire, the materials inside vaporize. The vapor travels through the pipe, and the cold water condenses it back into a liquid that you collect. What doesn't condense is sink. You must either burn it immediately or vent it safely. It's highly flammable. The liquid you collect is pyrolysis oil. It smells like a chemical fire, and it's toxic. It contains benzene, toluene, and other nasty compounds. Do not get it on your skin. Do not breathe the fumes. But it burns, and it burns hot. With some modifications, it can run diesel engines or fuel oil lamps. Its energy density is about 60% that of gasoline. The environmental cost is catastrophic. The health cost is significant. But when the choice is freezing to death or burning toxic fuel, most people choose burning. They're not wrong. Survival offers no clean options. So let's review what we've built. A biogas digester producing cooking fuel from waste, a thermal massed battery storing the sun's heat, a thermoelectric generator making electricity from fire, and a pyrolysis reactor turning trash into liquid fuel. 4 systems, 0 dependence on the grid. The total material cost in a functioning society might be $100. After the collapse, the cost is whatever you're willing to carry. Here's what nobody tells you about alternative energy. It was never really about saving the planet. It's about decentralizing power, both literal and metaphorical. Every kilowatt-hour you generate yourself is one less you need from someone else. It's one less point of failure, one less vulnerability. The grid failed because it was centralized, with massive infrastructure and single points of catastrophic failure. You're building the opposite. Small, distributed, resilient. It's ugly, dangerous, but effective. Will these systems power your old life? No. Your old life is gone. But they will power your new one. The one where you eat hot food, have light after dark, and don't freeze to death. The one where you retain the fundamental human ability to harness energy. While everyone else is burning their furniture and wondering when the government will fix things, you're building a gasifier from a paint can and moving forward. That's the difference. That's the gap that widens every single day. The blackout isn't temporary. It's the new baseline. And baseline just means you start rebuilding from here. If this level of practical collapse engineering is what you're looking for, subscribe, because we're not talking about hype. We're talking about what you need to know for Thursday.